My name's Will, BridgeworksGames.com. This is my buddy Luke. We are working on a infinite tank shooter. Kind of follows the mouse around, and that's actually what we're working on today. The tank has a little turret on top, and that turret's going to rotate depending on where we put the mouse on, even though we're using an orthographic camera, which is typically a pain in the keister. In other games, for instance, let's say our camera was right on top of our tank, looking downwards all the time. Having the turret follow the mouse would be really easy then. But because
super easy,
because we're using a weird orthographic perspective, it's going to be a lot harder to do, and it's going to require a lot more code, and it's ugly.
Okay.
Yeah.
So do we need to move the camera before we do any of this?
Let's do it. Yeah, let's do that. So the first thing I'm noticing is if you look on you're clicked on the camera, which is great, and then on the camera in the inspector and the camera component, you can see the fifth object down. It says projection is set to perspective. I think if we drop that down, we can choose orthographic.
Okay.
And it's going to change the camera perspective. Okay, so our game window on the bottom left, we can see that we're looking at the player's perspective, but it's more of a two-dimensional thing. So we're going to have to edit the transform. We can change the rotation. We're going to do 30 on, that's it. The next one's going to be negative 45. Cool. So this is actually looking what we want. We're just off to the side a little bit. So if we change let's try the Z. Let's see what the Z does for us. And that's okay. We're going to have to do a little bit of mix. A little bit of Z, a little bit of X, get us exactly where we want to be.
Okay. So just play around. This is centered X and Z. Okay. So then if we increase Y, right? Something like that.
Looks great.
Or do we, we probably want it facing more towards the front because is it going to be endless running up and to the right?
This is the way that I am anticipating doing it. So I would say let's keep it here for now.
Oh, really? You don't want it facing more towards where we're going?
Let's leave it here for now, and then we can always edit it afterwards.
Okay.
Especially with this code that we're doing, allows for a lot of flexibility.
Okay.
Yeah, there's a lot of vector math that's going on with this code. And the next thing I want to do is make the plane bigger. So plane is on, there you go. It's in the hierarchy, and then we can change the scale of it. Let's just make it 5 and 5, 5 or something. It's fine. Right now, we're just going to make it so big that it goes outside of the perspective of the camera.
Okay. Sure. Is that good?
That's great. That's great. Now, let's hit play. Let's see what it feels like.
Pretty good.
And then hit me with a jump.
Yeah, jumping still feels good.
Cool. Okay, great. So I'm liking this so far. We can always edit it too if we feel like we want to have a little bit more of a different angle or something.
Okay.
Great. So let's get that turret spinning. First thing we'll do for turning, that's the spinning the turret, is we need to reference the turret. So we'll go to the tank, and then we're going to open up the tank script. You remember how to do that?
Yeah, it's this.
Yeah, you got it. Great. We'll just call the turret a game object. So that starts anywhere you want. We can start on line 6. Create a new line to what would be line 7. Say public game object with a capital G. And then we'll call this turret. Now we'll save, and we'll go back to Unity. And I like to do that immediately because it's really easy to forget to do that step.
Okay.
Great.
Oh, and then are we gonna like drag something into this from the render or whatever, the tank stuff?
You got it. Look at you.
Okay.
Look at you. You know what you're doing.
Oh, hey, tank turret. And then we just bada bing, bada boom.
We're done. I can just cancel this whole tutorial.
No, please don't. No.
Ready to go.
No, not quite there yet. No, please come back.
We're now referencing our turret. Let's go back to our script.
Okay. So I can just go back to VS Code.
Yeah. Great. So in our update, we've got, what do we have? We have landing, that tells when it initially lands. We've got jump, jump man, and then we've got movement.
Mm-hmm.
So we need to add a new one. We're gonna add a new function. We're gonna call it follow mouse. Should I get picky about the F being capitalized?
Camel case, boy.
But for functions?
I don't know. I do camel case. I can do
No,
capital. I don't know. I don't know what the syntax norms are for this language. I do camel case for basically anything in JavaScript.
All right.
But that works for me.
Okay.
I have no complaints.
Hey, if you feel like I'm being pedantic, you just call me out on it and say,
No,
"Will,
it's okay.
calm your ass down."
Again, I don't know C#.
All right. We got our follow mouse.
Mm-hmm.
Next thing we need to do is kind of weird. Where the mouse is on the screen, we're going to shoot a raycast from that mouse point down into where it hits in the ground.
Is there a reason why we don't like draw a line between the tank and the mouse instead?
Yeah, it will always be off. The degrees are always going to be slightly off because of the way it's translating from the orthographic perspective of the world into the flat two-dimensional.
That makes a lot of sense.
If we were 2D on top, then there's no translation. It just...
Sure.
Yeah.
Okay.
First thing we're going to declare, it's a ray data type. So it's a capital R-A-Y. And I don't care what we call it. So space, we'll just call it lowercase r-a-y. Doesn't matter. It's very local. We're going to get rid of it soon.
Okay.
And then we're going to equal it to something. So equals capital C camera dot main dot, and main is actually lowercase. Sorry. It's a member. They lowercase the members, capitalize the functions, methods. So this one's a function, so capital S screen point to ray. Screen point to ray. Hey, you mind increasing the font size? Just
Oh yeah,
tab?
sorry about that.
Don't be. Cool. Perfect. Great. You can slap a semicolon. Okay, there you go. Or that. That's great. Let's put some arguments inside of there.
Oh,
And the only argument we're going to put in here is capital I input dot mouse position. Mouse with a lowercase m, since it's a member. Yeah.
I'll never get used to this, and that's okay.
You will. It only took me 3 years. You'll get used to it. Cool.
So you're saying these are members, right? What is that? Is that like a parameter?
Yeah. Yep.
Okay.
Yeah, you've got methods, and then usually they're private members within classes, but in our case, these are public. We can reference them.
So method and member.
Another way, yeah, method would be screen point to ray. That's the method. That's an object. Our object right now is our input object.
And then member.
Member there, which is the data type of that member is a vector 3, and it's telling us specifically where the mouse position is.
Gotcha. And this is just a method or a object, an object as well.
Yeah. I could get into the inefficiencies of what we wrote here. This is inefficient, but we'll get into
like processing wise or coding wise.
Processing wise, yeah, initial processing, but it's fine. All right, we'll add a new line, and we're gonna do capital R raycast and capital H hit. So raycast hit, one word. Yeah, there you go, great. And then we'll call it the same thing again. That's the data type. We'll just call it raycast hit with a lowercase r this time, just like we did the ray above. That's perfect. Semicolon. Actually, we don't need to. We're not going to set it. We're just saying, hey, this exists. Okay, cool. Next line. And this is going to be an if statement. If open paren capital P physics dot raycast capital R. It's a method. Sorry. And then open and close our parentheses again. So here we're going to have 3 arguments. The first one is our array, lowercase r-a-y. The next one,
R-A-Y.
yeah, r-a-y, which is the one
I heard array.
And yeah, no, that's absolutely valid. It's the one on line 81 is what we're using there as our first argument.
Okay.
Which is actually just a point. It's a position. The next one is, we'll use the word out. O-U-T space. And then now we're going to reference the one on 83. So raycast hit, lowercase r. Perfect. Great. And then the third argument is math, capital M, math F, dot, capital I, infinity. Beautiful. That's it. So what we're doing here, we've got a raycast. Starts from the specific position of ray, which is the...
wherever the mouse is.
Yeah, wherever the mouse is.
But drop down to the ground.
You got it. Drop down to the ground. And then the out says if it hits something, we return that back. That's what we're going to use inside of our if statement here.
So is the out what is determining what the ground is?
It's determining what it collides with. And in this case, it is going to be the ground.
Gotcha.
And we're actually going to, since we're in an if statement block, we can remove the semicolon. But we will need it when we do. Exactly. You got it.
I'm guessing this is just literally raycast into infinity.
Yeah, that's the length of it. Yeah, thanks for mentioning that. That's the last parameter. You're right. We should cover that too. Math.infinity. I don't know what that number is. It's a float. I mean, infinity doesn't exist, so I don't know what it is, but it's a large number.
I'm guessing as big as floats get.
Yeah, so we're going to now take this information we have from our raycast hit. That's going to be an argument, and we're going to create a new method here, a new function. Let's call it calculate target position.
Okay, so this is going to be
capital C. Calculate target position. Awesome.
I just wasn't sure if it was like a void or anything, or is that...
Well, right now we're calling it. We haven't written it out, and we're going to write it out
past
line
okay,
89.
Okay.
You're right, though. When we do on line 89 or 90, that's where we declare it as a void. Yeah. And yeah, will be a void. Great. So inside, we're going to take our raycast hit that we referenced. Yeah. And then, but we're going to say dot point, lowercase p. And that's the argument we're going to toss in there. And that's it, just one argument. And we can close it off with a semicolon. Cool. That is it for follow mouse. Now we're going to go past that brace. Perfect. And yeah, that'll be void. And then this one is, you got it. Inside, the argument is a vector 3. And we'll call it a capital V vector 3. Did you do it? You did do it. You're amazing. Look at you. That's the data type. We're going to call it hit. So we still want to go inside of our arguments in the function. And we'll do space hit. Perfect.
So why... So when it's a space, what is this?
Yeah.
Is this still a member?
Question. It's a variable. Yeah, it's no longer of a class because we declared that. We don't need a class object for our raycast.
Oh, we're just declaring a new variable.
We are... Yeah.
Or like a constructor kind of, or
no, it's definitely.
Or is it just defining? Is it just defining what kind of variables can be passed to this function?
You got it exactly.
Okay,
and so
gotcha.
That's what we're doing on line 87. Is we're taking our variable and we're passing it in.
Okay.
Yeah, perfect. So from here on in, we're going to reference it as hit, but it's the same reference as
the raycast hit dot point.
Yeah.
Yeah, gotcha.
Cool. Yeah, that's an awesome question. Okay, here we go. We've got 6 lines, and they're dense. So, to those viewing this, I apologize. Stick with us. You're amazing. I believe in you. First one's vector 3, capital V. Vector 3. Yeah, there you go. Let's just call this mouse screen to world. Yeah. Equals. We're going to reference our camera.main again. Yep, capital C, main, screen to world point. Awesome. That's it. And then inside of there is going to be the same thing, our argument, input, mouse position, exactly like we have on line 81.
So these are highlighted in the IDE like they're a function, right? But these are just methods of this predefined object in Unity, correct?
Yeah, you got it.
Okay.
Hypothetically, I don't want to do it now because I feel like we're going through a lot. But if we hypothetically went to the Google Documents and looked at camera, we would see the available methods that we can pull from and use, and we'll notice that these are on there.
Okay.
Cool. So here we go. Line number 2 of 6. This is a float. So lowercase f, float. We're going to call this y total. So you can use your camel case here if you want to. If you like it. I know you like a camel case. Equals hit, H-I-T, referencing that argument, dot y. So just the y coordinate, minus our mouse vector that we just made right there. So mouse screen to world, dot y. There you go. We're subtracting the 2 y's from both vector 3's.
Okay. What is the screen to world point? Is that...
Yeah, that's a really good question. Let's do it. I'll show you real quick. We'll go back into Unity just for a second. And it's okay that we're going to have all sorts of errors. Let's do, when you're on your mouse, right click and rotate your camera. We're going to flip around and look up in the sky. And then keep kind of rotate around a little bit. Oh, you know what? I'm sorry. First click main camera and then start looking around. There you go. Yeah, let's start looking around. Yeah, I'm still not seeing it. Okay. Let's go back to normal. We'll hit the 2D button. And then, well, actually, there it is. That's exactly what I wanted to see. If you zoom out just a little bit more, you can see that box around the camera.
Yeah.
Yeah. That is the screen that you have here. Watch this. If you take your... This is kind of hard to explain. You know the line that's dividing between the game window and the console window? There's a line in between if you put your mouse over those. Now, the game one, that's scene. Yeah, there you go. Game. Yeah, perfect. Click, hold, drag. Notice how the one in there is changing.
Oh.
Do you see that? So that's the screen that we're referencing here.
Okay.
So if you get out of the 2D mode in the scene view and change the camera angle just a little bit to where you can see both. There's another way to do it too. Rather than right clicking, if you hold Alt and then press left click, it's going to change the world's perspective as opposed to yours as the camera.
Okay.
So if you click main camera again while you're moving around, I want to see those. Yeah, you see how you can see those lines, right?
Yeah, sure.
And you can see there's a difference between the angle that the screen is at and the angle that the ground is at. So what this is doing is if it's going from screen to world point, it's translating that. And if it's going from world to screen point, it's translating that as well. Because the screen is a 2-dimensional perspective, and we're shooting down a ray from that 2D perspective down into the 3D perspective of the world at the angle that we need.
Okay.
Yeah.
And so the screen point is like this. Is that just like referencing the box?
Yeah, so that one's doing screen to world. So what that's doing is it's taking the screen, the 2-dimensional side, it's translating it into the world point. So it takes the mouse perspective and puts it into the...
Wherever it is in that box.
In the 3D space. Well, from the box to the world.
Gotcha.
Yeah.
Okay.
Line 3 of 6. We've got this. Float. New y. Camel case, yes. Equals. You ready? Shaking out, getting ready? Okay.
You're startling me, but yeah.
Again, y total Oh no, I'm doing the hand thing. I'm acting like I'm cool. Minus. Let's put this in parentheses for the case of like mathematical preference. So we're going to do hit.y minus turret. What are our turret? What is that? Is it turret? Okay, cool. Turret.transform.position .y. Yeah, so this looks crazy, but it's crazy. It's voodoo magic is what this is.
So y total, new y. So is the y total measuring where we're facing currently?
No, this is positioned specifically. So the turret is hanging above the tank. I shouldn't say hanging. It's sitting above the tank a little bit. I don't know, maybe 1 unit above the ground. And so that is what new y... Actually, that's not exactly what new y turns into, because we have turret transform position .y. Remember, all of these are .y. So they're all this, you know. We're only doing up and down right now. So we've got the turret transform position .y, and we'll actually hit .y.
Oh, is this so that wherever the mouse is, no matter what height difference it is from the plane, it's going to be the same because we're just measuring to the turret? Is that...
Yes.
Okay.
Yeah, you succinctly answered something I had a really hard time describing. One of the cool parts about this code, and which is something I was looking for when I asked the Portland Indie Gaming Group, is how do we get the same perspective if the tank is going and climbing an incline or going down a decline? How do we get that as well? So this code
the same.
covers that.
Well, because it doesn't matter.
Oh, it matters.
Well, I mean, like, because of this code, it doesn't matter.
Yeah, yeah, we're calculating it. Yeah, cool. Line 4. This one's not as bad. Float. Let's call it factor. Factor equals new y divided by y total. There you go. That's it. Okay, here we go. 5th line. It's a vector 3. We're going to call it target position. Or target pose, whatever you want to call it, whatever's easier for you.
So what is the previous line? Is that we're going to use that right now, I assume, and then it'll make sense?
Yeah. Actually, we're going to use it now, and it won't make any sense at all.
Ah, okay.
Yeah, we're just going to use it because some very smart people who know vector arithmetic way better than I do helped out with this.
I don't care about that.
Yeah, it's tough. Mouse screen to world. So, excuse me, equals. My bad. We got to have an equals there. Yeah. Mouse screen to world plus, and let's do open paren, and we'll get in the middle of both. I think we need to do both for, again, mathematical preference is all this is, or not preference, but order of operations. Hit minus mouse screen to world. Now you can do this with vectors. With 3 vectors. Vector 3s are just, a point. You got an x and a y and an x and a z, and you can subtract them. And that's what's happening here. We're subtracting both of them apart, and then right there, perfect. We're going to use the multiply factor right there. So times factor, and then we'll cap it off with a semicolon at the very end. Cool. Okay, and then this is the last part right here. Number 6. Turret dot transform dot capital L LookAt. So capital A. Yeah, open parentheses, target position. You got it. That's it. And that line right there, line 103, is actually what's changing the rotation of the turret.
So basically this gives us the direction we're looking at, and these make sure that the turret stays flat, right?
Yeah.
And then, I don't know, via some voodoo magic, this just makes the turret move.
I don't know what the multiplication is doing, because the multiplication is only added on the difference between the hit vector and the mouse to screen world vector multiplied, and then added onto the mouse to screen world point. But let's play it. I want to save this stuff and see what we get. See if we like it. What errors do we got? Physics does not contain a definition. Raycast. Okay.
Do I have the capitalization wrong?
Yes, capital C needs to be a lowercase c. There's no way for you to have known that.
Like there?
Well, rather I should say for future. Yeah, that's perfect. For future troubleshooting.
I think yeah.
You know, you could go to the Unity docs and you'll see that it has physics, and then it'll mention everything about that and raycast.
Yeah, well, I just assumed with how much trouble I'm having with capitalization that was probably the issue.
And you assumed correctly.
And I know that from my very limited amount of coding, but it's usually true. Okay. So
drum roll, please. So now when you have your mouse, let's do this. Let's maximize this. You can click the maximize on play. You see that button there in the... Yeah, there you go. You can click that. Yeah, hit play and it'll make it bigger and tell me what you think.
Whoa. Hey. That works really well.
Isn't that ridiculous?
That's pretty dumb that works so well.
Yeah, a lot of people are telling me, they're like, yeah, you need a 3-dimensional plane. The problem with 3D planes, so they call them raycast.plane, it doesn't allow for inclines and declines. Yeah. There it is. You got your turret rotating. And next, we're going to be building bullets that'll travel through the air. That looks like some sick dance moves, honestly. Like he's kind of looking around and kind of doing these, like, I don't even know, like some Michael Jackson something, moonwalking. Look at those hips.
Mm-hmm.
It's kind of sexy. Sexy little tank. You got those moves, little tank.
Kind of weird.
I like tanks.
That's fine.
Yeah, I'm tank sexual.
That's fine.
Don't tell my wife.
I won't.
You look so satisfied. You look so happy.
It looks good. It feels good.
I love it. Okay, so next video we're going to be working on creating a bullet, and then we'll also create like a muzzle flash. And yeah, that'll be next. Well, bye.
And I'm going to be honest, the times where I feel like I've been the most energetic and like good during these things, I've usually had some wine beforehand.